Nanocellulose is a term referring to nanostructured cellulose. This may be either cellulose nanofibers, CNF, also called microfibrillated cellulose, MFC, nanocrystalline cellulose, NCC, or bacterial nanocellulose, which refers to nanostructured cellulose produced by bacteria. CNF is a material composed of nanosized cellulose fibrils with a high aspect ratio, length to width ratio. Typical fibril widths are 5-20 nanometers with a wide range of lengths, typically several micrometers. It is pseudoplastic and exhibits thixotropy, the property of certain gels or fluids that are thick, viscous, under normal conditions, but become less viscous when shaken or agitated. When the shearing forces are removed, the gel regains much of its original state. The fibrils are isolated from any cellulose-containing source including wood-based fibers, pulp fibers, through high pressure, high temperature and high-velocity impact homogenization, grinding or microfluidization. Nanocellulose can also be obtained from native fibers by an acid hydrolysis, giving rise to highly crystalline and rigid nanoparticles, often referred to as CNC or nanoescers, which are shorter 100 seconds to 1000 nanometers than the nanofibrils obtained through the homogenization, microfluidization or grinding routes. The resulting material is known as nanocrystalline cellulose, NCC. Nanocellulose/CNF or NCC can be prepared from any cellulose source material, but wood pulp is normally used. The nanocellulose fibrils may be isolated from the wood-based fibers using mechanical methods which expose the pulp to high shear forces, ripping the larger wood fibers apart into nanofibers. For this purpose, high-pressure homogenizers, ultrasonic homogenizers, grinders or microfluidizers can be used. The homogenizers are used to delaminate the cell walls of the fibers and liberate the nanosized fibrils. This process is responsible for the high energy consumptions associated with the fiber delamination. Values over 30 mWh/ton are not uncommon. Pretreatments are sometimes used to address this problem. Examples of such pretreatments are enzymatic/mechanical pretreatment and introduction of charged groups, for example through carboxymethylation or tempo-mediated oxidation. It has been shown that energy consumption can be heavily decreased using these pretreatments, and Lindstrom and Enkerfers has reported values below 1 mWh/ton. Cellulose nanoescers, a more crystalline form of nanocellulose, are formed by the acid hydrolysis of native cellulose fibers, commonly using sulfuric or hydrochloric acid. The amorphous sections of native cellulose are hydrolyzed, and after careful timing, the crystalline sections can be retrieved from the acid solution by centrifugation and washing. Cellulose nanoescers are rod-like highly crystalline particles, relative crystallinity index above 75%, with a rectangular cross-section. Their dimensions depend on the native cellulose source material, and hydrolysis time and temperature. Recent breakthroughs in nanocellulose production were announced April 2013 by R. Malcolm Brown Jr. Ph.D., a biology professor at the University of Texas at Austin, who presented his team's findings at an American Chemical Society conference in New Orleans. Borregaard, a Norwegian biorefinery company based in Sarpsborg, Norway, announced in October 2014 that they are investing in a facility to produce microfibrillated cellulose on a commercial scale. The production facility will have a capacity of 1,000 tons per year, and is scheduled to be operational from Q3, 2016. American Process Inc., a biorefinery technology development company headquartered in Atlanta, Georgia, has also recently announced a manufacturing process using sulfur dioxide and ethanol pretreatment of biomass to produce both cellulose nanofibrils and cellulose nanocrystals and lignin-coated, hydrophobic varieties of each. Icarcercot Nanocellulose Pilot Plant, a unique facility for production of nanocellulose from cotton and other agrobiomass, was inaugurated by Padmavis Bhushan and Dr. R. A. Mashelkar in Mumbai, India on August 21, 2015. This pilot plant was funded by World Bank-supported National Agricultural Innovation Project of Indian Council of Agricultural Research, New Delhi. This pilot plant has the capacity of 10 kilograms nanocellulose production per shift of 8-hour operation and uses patented energy-efficient and eco-friendly technologies. Both nanocrystalline cellulose and nanofibrillated cellulose can be produced in this plant, both in aqueous and dry form. This is established to act as an incubation center for new entrepreneurs and as technology demonstration unit.